Hey there, party people. I just got done with my control box, so I thought I'd step through some of the wiring. This is not an official walkthrough, and I am an amateur, so please do all this at your own risk. This board's made by CNC 4PC. It is the C11 breakout board. Let's go ahead and get started. First things first, let's talk about the power input. The top left, we have ground and 5 volt. This can connect to a USB or a external 5 volt power supply. Next up, we have the 5 volt plus and enable pin at the bottom. Here you could hook up a switch. This would act kind of like a safety measure to keep things from getting enabled in case you applied power to the machine and didn't want them to be enabled. But for now, I just have mine jumpered because I don't have a switch and they'll always be enabled that way. Next up, we have terminals for ground and pin 1. I don't really know what these are used for currently, so for now they are just left alone. Now we get into the actual channels for the X, Y, and Z. The first one being X, and it goes pin 2, ground, or common, and pin 3. And what this translates to is step, common, and direction for this one axis. The other ones also have the same configuration, so hopefully it shouldn't be too confusing. And next up we have the Y. It should be 4, common, 5, and that's step, common, direction. And now we have the Z channel, which is another step, common, direction, but this time it's pin 6, common, 7. And now we have the A, which should be 8, common, 9 for step, common, direction, and this will be slaved over to the Y axis in my current setup. That'll happen in the Mach 3 software, so we won't have to worry about that physically here. And as I was saying, there's a step, common, and direction for each one of the channels, and these all get wired down to your servo driver. There also appears to be a 14 ground and 16. It's similar in setup to the other channels. Possibly this could be used for another axis or maybe spindle control. And at the end of the terminal block, you'll also see a pin for 17. 17 is usually used for the safety charge pump signal in most CNC setups, so you can tie into this here if you need to. And I'll make a little more room because we have to include the parallel port input to the board. We also have an input for 12 volt DC, which comes from an external power supply. And what this does is gives you the ability to have an output right next to where we plug these wires in that you can control the voltage 0 to 10 volt. With potentiometer, and then from the board you can then use that variable voltage to control something like a speed controller or a variable frequency drive VFD. Next we have another 5 volt power input. This connects to another 5 volt power supply, or if you have a strong enough one you can connect it to the same one that's connected to the main power supply. What this does is this just powers the components that are connected to the board, not the board itself. I'm pretty sure that's what it does. I know you need it in order to get anything to happen. There's also some extra terminals here so you can daisy chain anything else that might need 5 volt power supply. Next up we have the block for the 2 relays on the board. Now these can be wired so it's something like a normally open switch or something that's a normally closed switch, whatever you need. Now the inputs are in pairs, so we have 5 volt 15, 5 volt 13, then we have a ground 12, a 5 volt 11, and a 5 volt 10. I think that ground might have been mislabeled. Now, the 10 pin is usually used for e-stop, as I gather, but in my setup I have nothing connected to it because I haven't bought an e-stop switch yet. Probably not the safest idea, but moving forward. Now the inputs can be jumpered to either use a pull-up or pull-down resistor, depending on how you want each one of the inputs to be used. For example, I am using 15 for my limit switching, and with limit switching you can have them run in series so that if one gets opened up it breaks the chain, or you can kind of run them in parallel to where they're normally open, and if any one of them closes it then closes the chain. So depending on how you have the jumper set is how that will behave, and will determine which one to use. Now for 13, 12, and 11 I'm going to be using these as my homing switches for X, Y, and Z. And I haven't quite decided if I'm going to do my limit switches in parallel like this or in series. Oh, one thing I forgot to draw is the output pass-through parallel port. So if you ever need signals to anything else, you can just hook it into this parallel port. And right next to the two square relays that you see on the board, you should see the pins for the pull-up, pull-down resistor configurations for 15, 13, 12, 11, and 10. Now these can be jumpered to the left so that they're pull-down resistors, or jumpered to the right so that they use pull-up resistors. Now a little bit to the left you'll see the jumper pins for the safety charge pump. They're numbered 1, 2, and 3 going from the bottom. And if you jumper 1 and 2 together, that'll turn the safety charge pump feature off. If you pin 2 and 3, or jump pin 2 and 3 together, it'll turn it on. Now moving a little bit more to the left, we have the pins for how the common wires in our channel configurations behave. And if you jumper pins 1 and 2 together, this makes the common wire on our channels act as a 5+ volt. If you jump them to pins 2 and 3, this makes them act like ground. Oh, one thing I forgot to draw was that there's a little potentiometer here. That's where you adjust the voltage going out from the 12 volt. And this sets it to a max between 0 and 10 volts. I also wanted to give some examples of how these relays can be used. Maybe you have a coolant system that needs to be turned off and on, or maybe a vacuum system. Really, this board has quite a bit of features. I'm not expecting to outgrow it anytime soon. Anyway, thanks.